You know, light is something we all take for granted. We flip a switch and suddenly a room is bright. But have you ever stopped to think about what that light really is? Not just the sunshine that warms your face or the lamp that illuminates your desk, but what it really does. From the point of view of physics, light is not just light. It's energy. Energy that travels, bounces, bends, and even carries information across the universe. Every color you see, every flicker, every glow is energy moving in a very particular way. And that's fascinating because energy is what makes things happen. It's what moves the universe. So today, let's take a little journey, not just to admire the light, but to understand it as something tangible, measurable, and endlessly surprising. Because when you see light as energy, the world suddenly becomes a much more exciting place. Have you ever stopped for a moment to really look at light? Not just glance at it, not just notice that it makes things visible, but to think about what it actually is. I mean, we live in a world bathed in it. Every morning, the sun spills energy across the planet in waves that are older than human civilization itself, and we hardly even notice. And yet, light is not just what lets us see a flower or read a book. Light is energy. It's motion. It's particles and waves dancing together in a way that is both precise and mysterious. And it's fascinating because it's the way the universe talks to us, the way it shows itself. Energy is what makes the universe happen. Without it, nothing moves, nothing changes, nothing exists in any meaningful way. And light is one of the most elegant forms of energy, traveling effortlessly across the vast emptiness of space to tell us stories that are billions of years old. Now, think about this for a second. Energy comes in many forms. We feel kinetic energy when we run, potential energy when we lift a rock, thermal energy when we touch something hot, chemical energy when we eat food. But light is different because it's a form of energy that can travel across empty space. A rock has mass, you can touch it, you can throw it. But light, it doesn't need a medium. There's no air in outer space, no water, nothing, and yet light zips across, carrying energy all the same. That's extraordinary. That's something you can't ignore. And this is why, from a physics standpoint, light isn't just a phenomenon. It's a tool, a messenger, a carrier of energy, information, and possibility. What do I mean by this messenger concept? Well, light interacts with matter. When sunlight hits a leaf, the energy in the photons, the particles of light, is absorbed by the leaf's molecules. That energy doesn't vanish, it is converted. Some of it becomes chemical energy, stored in sugars, fueling the plant and ultimately fueling every organism that relies on plants, including us. The energy from light travels from the sun, which is 93 million miles away, across space and ends up in the food we eat. If you stop and think about that, it's remarkable. Every bite of food carries a history of energy that started as light. But let's take a step further. Not only is light energy, it's quantized. That's a fancy way of saying that light comes in discrete packets called photons. You can't split a photon in half, just like you can't split a raindrop into two exact pieces and still call each one a raindrop. Each photon carries a specific amount of energy that depends on its frequency or color. Red light has less energy per photon than blue light. And it's incredible to think that the colors we see, the rainbows, the sunsets, are all just different amounts of energy traveling in waves we can detect with our eyes. Energy is color. Energy is motion. Energy is what makes our world vibrant, literally and figuratively. Now, one of the most delightful things about light is that it behaves in ways that seem almost magical. Sometimes it acts like a wave, spreading out, bending, interfering, creating patterns. Sometimes it behaves like a particle, striking one point and delivering its energy precisely. And that's not a trick of nature, that's the truth of it. Light is a dual entity, wave and particle at the same time, and both descriptions are necessary to fully understand the energy it carries. It's the same energy whether it behaves as a wave or a particle. Physics teaches us that energy doesn't care what we call it. It just moves, transforms, and interacts. And in the case of light, it interacts in ways that are both predictable and astonishing. Let's talk about speed. Light travels at an incredible velocity, about 299,792 kilometers per second. That's fast enough to circle the Earth more than 7 times in a single second. And what's really interesting is that this speed is constant in a vacuum, no matter how fast you are moving. That tells us something profound. Light is not just a form of energy, it is a cosmic speed limit, a fundamental thread woven into the very fabric of space and time. All. The energy it carries is moving at the ultimate speed, racing across the universe, never slowing, never stopping. When you turn on a lamp, the photons reach your eye in an instant, but in the larger scale of the cosmos, that same light might be ancient, traveling for millions of years before touching a planet somewhere far away. And because light is energy, it can be transformed. Think of a solar panel. Sunlight hits it, and the energy carried by photons is converted into electricity. That same energy can power your home, your computer, or a spacecraft traveling millions of miles. Energy never disappears, it just changes form. Light is a perfect example of this principle. It travels, it strikes, it transforms, and its energy continues to do work in the world. Every photon that reaches Earth from the sun is a tiny ambassador of energy, waiting to be absorbed, converted, and used. But there's more. Light energy interacts with matter in ways that teach us about the universe. When light passes through a prism, it separates into a spectrum. What is happening here is that the energy in the light is interacting with the material in the prism, bending at different angles depending on the wavelength. That separation of energy is visible to the eye as a rainbow, but the principle is universal. Every color, every photon carries a specific energy signature. Astronomers use this fact to study stars and galaxies billions of light years away. By looking at the energy carried by light, we can know the temperature of a star, its composition, even the speed at which it is moving. Energy is not just something that moves and does work, it's a storyteller. Light energy is also responsible for one of the most critical processes on Earth, photosynthesis. I mentioned it briefly, but it's worth marveling at. Plants capture photons, convert that energy into chemical bonds, and produce oxygen as a byproduct. That tiny conversion supports nearly all life on Earth. Without the energy and light, life as we know it would not exist. And yet, it's happening in every leaf around us, constantly, quietly, elegantly. Light brings energy, energy sustains life. It's as simple as that, and yet as profound as anything in the universe. Let's not forget about the energy that light carries in less visible ways. Infrared light warms your skin. Ultraviolet light can give you a sunburn. Even X-rays and gamma rays are light, high-energy photons traveling through space. All of them are the same fundamental entity, light, but with different amounts of energy per photon. And the higher the energy, the more impact it can have. Energy in light can heal or harm, it can illuminate or destroy, it can signal or change matter. It's versatile, fundamental, and awe-inspiring. Even in our daily technology, we harness light energy in extraordinary ways. Lasers, for example, concentrate photons into coherent beams that carry energy precisely and powerfully. Fiber optic cables transmit light energy over vast distances to carry information that connects the entire world. Light energy is not just a natural phenomenon, it's a human tool, and we have learned to manipulate it with incredible precision. That ability to channel light's energy, to focus it, redirect it, measure it, and use it, shows just how fundamental energy is to our understanding of the universe. There's also something poetic about light as energy. It moves, it changes, it interacts, it carries a story. And yet it is bound by rules, laws of physics that are consistent, elegant, and universal. It reminds us that the universe is intelligible, that energy is not random, that there is a rhythm and a pattern underlying everything we see. Light is the universe's way of revealing its secrets. By studying it, by observing it, by measuring the energy it carries, we are participating in that story. We are witnessing the fundamental processes that govern reality. And it doesn't stop there. Light energy is not static. It can bend, refract, diffract, and interfere. The interference patterns we see in experiments are not just curiosities, they are direct evidence of the wave nature of energy. When light shines through two slits, It creates a pattern of bright and dark bands on a screen. That pattern is energy organizing itself in space, moving according to principles that are precise and beautiful. And yet, if we look at light as photons, those same photons arrive at discrete points, delivering their energy in quantized bursts. The duality is striking, but the energy remains. Whether as waves or particles, it moves, it interacts, it transforms. Consider the energy in the sunlight that reaches Earth in a single hour. Enough to power all of humanity's energy needs for an entire year. That's staggering. It's almost incomprehensible. And yet it's a simple consequence of the fact that light is energy. Energy that comes in abundance, traveling vast distances to reach us. And here we are, tapping into it, learning from it, marveling at it. Every sunrise, every ray of light is a reminder that energy is fundamental, that light is no just illumination, but a vehicle of power and potential. And finally, think about how light energy connects everything. The photons reaching your eye from the sun have traveled across space, interacting with nothing along the way, yet carrying energy that influences life, technology, and even your mood. Light links the cosmos to the microscopic, the distant stars to the cells in your body. Energy moves in ways that are immediate and universal, visible and invisible, simple and astonishing. Light is energy, and energy is the heartbeat of the universe, the thread that weaves together matter, motion, and life. Imagine for a moment that you are in a completely dark room. No sunlight, no lamp, no glow from a screen, just darkness. At first, you might feel a little disoriented. You might feel a sense of emptiness or even fear, because our brains are wired to understand the world through light. And yet, if we think about it carefully, what is it that we are missing in that darkness? We are missing energy. Light is energy, and without it, the room is simply a place where energy isn't reaching our senses. But the moment a single photon enters that room, the moment a ray of light reaches your eye, everything changes. Suddenly, you can see. Suddenly, energy is at work. This is the simplest, most fundamental lesson about light. It is not decoration, it is action. Light energy is everywhere, whether we notice it or not. When the sun rises over a mountain, the photons streaming toward Earth carry energy that has traveled millions of kilometers across empty space. That energy interacts with the atmosphere, scattering and bending to create colors that are astonishing in their subtlety. We see the reds, the oranges, the pinks of a sunrise, and each of those colors represents a different amount of energy, a different frequency of photon, and a different way that energy interacts with matter. Energy is color. Energy is motion. Energy is life. And the fact that it has traveled so far, unaffected by the void of space, tells us something fundamental about the universe. Energy moves, and light moves energy with incredible fidelity and precision. Now, consider the way light energy behaves when it encounters matter. A photon hitting a leaf doesn't just bounce off. It is absorbed, converted, and transformed. That energy becomes chemical bonds stored in the leaf, waiting to be used. And when we eat plants or animals that eat plants, that same energy flows through our bodies. Every movement we make, every thought we think, every heartbeat we feel is fueled in some way by photons that started their journey from the sun. Energy is universal, and light is one of its most elegant expressions. Light is a delivery system, moving energy across space and time in a way that is both simple and astonishingly complex. But light is not only a carrier of energy, it is also a carrier of information. When a beam of light reaches our eyes, it tells us about the world around us. The energy in the photons encodes details about objects, distances, shapes, and colors. When we look at a distant star, the light that reaches us has traveled across the universe, sometimes for billions of years. The energy in that light carries information about the star's temperature, its composition, and even the motion of the galaxy it inhabits. Energy is the universe's way of speaking to us, and light is the medium of that conversation. By studying the energy carried by photons, we are able to understand phenomena that are unimaginably far away, both in distance and in time. Think for a moment about the dual nature of light, as both wave and particle. When light behaves as a wave, its energy spreads, interferes, and creates patterns. The ripples of energy can combine to create constructive or destructive interference, leading to phenomena like rainbows, diffraction patterns, and the shimmering of water. The energy in these waves is not lost. It moves, it shifts, and it reorganizes. On the other hand, when light behaves as a particle, energy is delivered in discrete quanta, photons. Each photon carries a specific amount of energy and interacts with matter in a precise, measurable way. Whether wave or particle, the energy remains. The universe doesn't care what model we use to describe light. The energy is real, it moves, and it does work. Now, let's explore the practical ways humans harness light energy. Solar panels are perhaps the most obvious example. They capture photons from sunlight and convert that energy into electricity. That electricity powers homes, industries, and even spacecraft traveling through the solar system. The photons themselves may have traveled millions of kilometers, and once absorbed, their energy is transformed into a completely different form, ready to do work in our world. That's the magic of energy. It never disappears. It only changes form. And light is one of the most versatile tools for this transformation. Even in medicine, light energy plays a crucial role. Lasers concentrate photons into coherent beams that can perform delicate surgeries, target cancer cells, or deliver precise measurements in diagnostics. Infrared light warms tissues, ultraviolet light sterilizes surfaces, and X-rays reveal structures invisible to the naked eye. In every case, light is energy interacting with matter, doing work, and enabling us to understand, heal, and manipulate our world. It's remarkable to think that something so intangible can have such tangible effects. Let's not forget about the astronomical implications of light energy. The photons from distant stars carry energy that tells us the story of the universe itself. By analyzing the energy spectrum of starlight, astronomers can determine the chemical composition of stars, measure their temperatures, estimate their distances, and even infer the expansion of the universe. Energy is the medium through which we perceive the cosmos. Without it, the universe would be a silent, invisible place. Light makes it observable, measurable, and ultimately comprehensible. Consider also the incredible range of energy that light encompasses. Infrared light, which carries relatively low energy per photon, warms our skin and drives weather patterns. Visible light carries more energy and allows us to perceive the world in color. Ultraviolet light carries even more energy, triggering chemical reactions and sometimes causing damage. X-rays and gamma rays carry extraordinary energy, capable of penetrating matter, initiating nuclear reactions, and revealing hidden structures. It's the same fundamental phenomenon, light, but with energies spanning many orders of magnitude, each with unique effects and applications. The energy in light is versatile, adaptable, and powerful. Light energy also teaches us about the nature of the universe at a fundamental level. When light bends near a massive object like a star or a black hole, it reveals the curvature of space-time itself. This bending of light, gravitational lensing, demonstrates that energy does not exist in isolation. It interacts with gravity, with matter, and with the very fabric of the cosmos. Light is not just energy traveling in a straight line. It is a probe of the universe, a messenger that reveals the invisible contours of reality. Furthermore, the energy in light is a tool for discovery. Experiments like the double-slit experiment show that photons can interfere with themselves, creating patterns that defy classical intuition. These experiments reveal the probabilistic nature of quantum mechanics, showing that energy in light is not merely continuous and predictable, but also governed by probabilities, uncertainties, and astonishing complexity. Energy is predictable yet mysterious. Light is both simple and intricate, and understanding it allows us to glimpse the profound workings of the universe. On a more human scale, light energy shapes our daily lives. Sunlight regulates our circadian rhythms, influencing sleep, mood, and health. The warmth of light affects climate, agriculture, and ecosystems. Even artificial light, carefully designed and controlled, allows humans to extend productive hours, create art, and explore the microscopic and macroscopic worlds alike. Energy in the form of light is not just a scientific curiosity, it is an intimate part of existence, a force that sustains, informs, and transforms life on Earth. Consider the energy in a rainbow. Sunlight refracted through droplets of water separates into a spectrum of colors, each carrying a distinct energy per photon. That simple, everyday phenomenon is a demonstration of the principles of physics in action, energy traveling, interacting, bending, and manifesting as color. Every photon in that rainbow is a testament to the universality of energy, the consistency of physical laws, and the beauty inherent in the motion of light. Finally, think about the long journey of light across the cosmos. Photons from distant galaxies may take millions or even billions of years to reach us. The energy they carry encodes a